Okay, stream, we're going to be starting in just a second. I just need to open up a few websites before we start. This is the wrong one. So open up the right one in just a second. There we go. And there we go. Okay guys, let's get started. So today, let me just share my screen. Okay, so today we're just going to be learning about, okay, I need to share. Okay, so today we're just going to be learning about stuff like inverse variations and other stuff from Algebra 2. So let's get started. Getting to know a rational function. So a rational function is basically like when there's like a rational function. Let me just try it. So a rational function, so I think this is like a type of rational function. So there's like x plus like 1 over like y plus 1 is equal to x 2x minus 2 over 4y, it's supposed to be a y, minus 6. So I think this is like a type of rational function. This is a type of rational function. Let me just redo that. This is a type of rational function, and yeah, that's and so here's another type of rational function. So if you have like something like this, and there's a fraction over here, and x is on the bottom of the fraction, then then this is also a type of rational function. So yeah, those are rational functions. So let's see what this looks like. So k is a constant number. So a constant number is where like you replace the k with a number, whereas for x you don't replace it with a number. So yeah, it's going to be something like y equals 10 over x. And that's going to look something like this graph right here. See, we can use a tool called desmos.com. And if we go over here, then we can like graph some cool graphs and stuff. Let's go to graphing calculator section. And this gives us like a graph thing to work with. So as you can see here, to do y equals 1 over x. See, as you can see, it looks something like 2, I guess. I don't know what you call these. I guess it kind of looks like a hyperbola, but it's like twisted this way. So it's diagonal. I think that's what it looks like. And if you put like a negative over here, it's gonna become this way. Oops. It's gonna become this way. And so yeah, now you can like translate it and stuff, -1. Or you can like put stuff. So yeah, Desmos is pretty cool. And this can be like 5 or like 1000. So it's like super close together. So yeah, that's pretty cool. So yeah, you can do stuff like this. And So let's get back to discussing rational functions and inverse variations. So notice this graph is not continuous. It like splits in the middle, and these lines, these curves, never reach this axis or this axis. So as you can see here, like it gets super close, but it never actually reaches it. So if we do 1 over x, go to the home page. As you can see here, like if you, as far as you zoom out, it just zooms out further and looks like it's right on the x-axis or y-axis. But if you zoom in like super close, you can see that it's actually not on the x-axis or y-axis. See, as you can see, like it's very close, but it's not there. So yeah, it never touches the x-axis. It never touches the y-axis for 1 over x. So if it's like that, then the place where it never touches is called an asymptote. So an asymptote is like a place where like the graph tries to reach it, but it never can. So it just goes closer and closer, and it gets infinitesimally small. So yeah, no, the distance between the asymptote and like this graph gets infinitesimally small as you go on and go on the axis thing. So yeah. Notice the graph is not continuous. It has a break in the middle as the curve gets closer and closer to x equals 0. This makes sense if you think about it. So basically, yeah. And now it states like the reason why that happens, because of algebra. So as you can see here, the equation for this is y equals 10 over x. So you guys know how like anything divided by 0 does not have an answer, right? It's like infinity, kind of, or undefined. So yeah, that's why like that happens. I'm just trying to write undefined. Okay, that does not look like undefined, but whatever. So let's erase this. So what that happens is if you make x equal to 0, and you so over here obviously x is 0 for the vertical asymptote because the origin is 0, 0, and the y-axis is on x equals 0, so yeah. So if you make x equal to 0 in this equation, you get undefined. So like there's no point for that. That's why this doesn't like meet over there. It also doesn't meet here because of the same reason. So if you like if you solve for x in this case, so solve for x means you have to like multiply over there. Sorry, let's just like flip the fraction. Let's not do that. So the first thing we're going to do is we're going to divide both sides by 10. So that makes y over 10 is equal to 1 over x. So now we can flip the whole equation upside down to get the value of x. So if we do that, we get x over 1, or just x, is equal to 10 over y. So if you look at this now, and you make y equal to 0, you get undefined. So yeah, that's why y equal to 0 also does not work. That's why this line also does not work. So yeah, x is equal to undefined. So you can write this as like that. So this means like there's no answers, kind of. So yeah, that's why there's asymptotes for this. And yeah. Let's just clear the screen. And this just shows how you can like translate it and move like the graph over on the x-axis and the y-axis. So yeah. So there are many real world situations where inverse variations occur. Unlike direct variation, as one variable gets bigger, the other variable gets smaller. Use some experiences in everyday life as examples. As you go faster in a car, it takes less time to get to your destination, right? Written mathematically, where k is some constant distance, also written as speed times time equals k, and that is the distance formula. So yeah, that's pretty cool. So here's another example, kind of. Yeah, so inverse variation. So this is also called an inverse variation because it's like it gets bigger and bigger the closer you get, and it gets smaller and smaller the farther away you get from the y-axis. So yeah, that's why it's called an inverse variation. So now let's move on to the next topic, which is rational equations. So rational equations, like what was just said, are basically like. Okay, this is a self-check. We don't need a self-check right now. So rational equations, they basically again look like this. So they're like y is equal to k over x. This is one way to write an inverse variation or a rational equation. So yeah, let's learn about what rational equations are. Let me first clear my screen. Solving rational equations. Rational equations are equations with one or both sides of the equation containing a rational expression. So what is a rational expression? It is an expression with a numerator and a denominator that are polynomials. Or another way of saying it is a rational expression is the ratio or fraction of two polynomials. So yeah, this is talking about like my other example of rational expressions where I just gave an example like x minus 1 or something like that over y minus 1 is equal to 2x plus 1 over like 4x. Sorry, that's supposed to be a y. And that does not look like a 4. That's 4y minus 6. So that's kind of what it looks like. So yeah. So let's scroll down. This is an example of a rational equation, by the way, which is what I just said. So yeah, see, this is also an example of a rational equation right here. So as you can see, like two fractions, or three in this case, are equal to each other, kind of. But like two of the fractions are getting added to each other. So that just turns into one fraction really fast. So, and the two fractions are equal to each other. So yeah, that's basically a rational equation. It's where two fractions are equal to each other. That's the basic definition. So let's see how to solve a rational equation. So let's use this guy's example as an example for solving it. So the first thing we have to do is we have to get rid of the fraction part. So what we're going to have to do is we're going to have to find the least common denominator. So you guys remember how like when you had to add, when you're in like 3rd grade or something, like you had to add like 1 over 5 plus like 1 over 6. Like, you had to get a common denominator for this. You had to get a least common denominator for this to work. Remember that, guys? So the least common denominator, obviously, you have to multiply this, or you can find factors that are like similar, or no, you can find factors that are the same and multiply the factors that are not the same to each other. So basically you have to do 5 times 6 in this case. So we have to multiply this equation by 30 over 30, and we have to multiply this equation by 30 by 30. 30 by 30. So that gives us basically that gives us so I was trying to say it like in a different way. So this is what you actually have to do. You have to multiply this equation by 30 divided by 6, because this equation has this fraction has 6 as the denominator. So you have to do 30 divided by 6, which is you have to do 30 divided by 5, so that's 6. And now you have to do 6 over 6 times 1 over 5, and that gives us 6 over 30. And yes, I know this can be simplified, but let's just add both of these together before it's simplified. And for this one, you have to multiply this equation by 5 over 5. And remember, we're not breaking any rules here, because 5 over 5 is just 1, and 6 over 6 is just 1. So we're just multiplying 1 to both of these. So yeah, we're not really breaking any rules. So that's 5 over 30. And now, since they have a same denominator, we can add these two together. And that gives us 11 over 30. So yeah, basically that's how you do it. And this is for like the 3rd grade problem. But let's use the same concept on like this kind of problem. So basically you have to add these together. And to do that, you need a common least common denominator, and obviously that's going to be x times x plus 2. So we're going to need to multiply this equation by x over x, and we're going to need to multiply this equation by x over 2. I don't have any space to write it. We have to multiply this equation by x over 2. Sorry, x plus 2 over x plus 2. So yeah, that's how you do that kind of thing. So now after you do that, you should get something like 5. Okay. Lagging a lot. So we have to get something like 5x over x squared. Or no, let's just not do that squared. Let's just not simplify this. Let's just do x times x plus 2. This is what we have on the bottom. Okay, so this is a common denominator, so it's common for both fractions, so we can just have a same denominator for both of the fractions. So we can just have like that, and we can add plus 3 times x plus 2 on top, and that's just going to be 3x plus 6. So now we can add these two on top. We can just simplify the whole equation generally. And we also have to multiply x to this also, because so this will also have a common denominator. So yeah. So after we do that, it should give us an equation like 5x, okay, no, there's not going to be enough room, 5x plus 3x or 8. So 5 plus 3 is 8, so that's how I got 8. So that's 8x plus 6 over x times x plus 2 and now we can find what this is equal to. So we have to do 10 times x, that's 10x divided by x times x plus 2, and now we can solve this equation. So basically, since these have common denominators, we can just multiply this common denominator to both sides, and that'll just effectively just cancel this out. So yeah, now we have 8x plus 6 is equal to 10, and now we can take 6 to the other side, so we have to subtract 6 from both sides. That'll cancel this out, and that'll make 10 minus 6, which is also 4. So we have 4 is equal to 8x, and we have x is equal to 1 over 2. As you can see, that's kind of what he did here, except he simplified it a lot. And over here, you see that we don't get the same answer. So, something wrong. So basically, let's just look at what he did. So he found that the least common denominator is x times x plus 2, because just like my example with the 5 times 6, you have to like multiply these kind of to get what you want. And now you can multiply x times x plus 2 to both sides, and as you can see, that makes like this have a distribution sign and this have a different distribution sign. So basically, like this gets multiplied to this and this individually. So basically, you can cancel this out, and you can and for this one, you can cancel x, but leave the x plus 2 over here. So that means that we take out the denominators and effectively the fractions in one blow. And now, as you can see, we get this answer right here. So yeah, we get this when we simplify this. And now you can take like 6. Now you can simplify this and take 6 to the other side. You can take 6 to the other side. No, you don't. You can't do that, because then that's gonna. So you want to like isolate the x's. So yeah, that's why you don't take 6 to the other side, because that's useless in isolating the x's. So you have 5x plus 3x, and that's 8x right here. And now you can subtract 8x from both sides to have the x isolated on this side. So you have 10x minus 8x, and that's 2x. So now you have 2x equals 6, and you divide by 2 on both sides, and you have x equals 3. Sorry for the confusion there. I was trying to like elaborate on this formula a little bit, but I guess I failed. So yeah. So basically, let's try this example again. So the first thing we have to do is we have to like make parentheses over here, and we have to multiply both sides by this times this. So we have x minus 5. Oops, looks like we don't have luck today, so we don't get free time. So we don't get free time for the Zoom meetings. Is what I mean. So now you have to do x minus 5 times x, and you have to do this to the other side also. So you have x minus 5 times.
On the right side, is it x minus 5 or is it x minus 9?
Yeah, this looks like a 9, but it's a 5.
Okay.
Okay, there we go. Looks less like a 9 now. So now you can like distribute this, and you can cross this out for this one. Cross this out for this one. So now you have to multiply x minus 5 for over here, and you have to multiply x over here. So you have x, because 1 times x is still x. So you have x plus 3 times x minus 5. So let's just do that over here really fast. So 3 times x minus 5. So you can distribute this over here. Distribute this over here, and you get 3x minus 15. So yeah, and after you get 3x minus 15, you can just put it over here. 3x minus 15. And this is equal to, cancel this out, and you have 7 times x. So that's 7x. So basically this is equal to, so x plus 3x is 4x. So you have 4x plus, sorry, that's a minus 15x. There's no x over there, by the way. There's no x for 15, so you have 4x minus 15 equals 7x. And so this is your equation. Now you have to bring this to the other side, so we can subtract x on both sides, so that cancels this out. And you have 7 minus 4x on this side. So if we do 7x minus 4x, we get 3x, which is equal to negative 15. So we just write this the other way, and it becomes 3x. Come on, okay. 3x equals negative 15. And now you can divide by 3 on both sides. Divide by 3 on both sides. This is supposed to be a 3, by the way. Doesn't look very much like it. So now this cancels this 3 out, and you have negative 15 divided by 3. And that gets you x is equal to negative 15 divided by 3, or negative 5. Okay, that just looks weird. 5. Perfect. So yeah, that's what you get, and that's how you get it. And let's see if we got the same answer as this guy. And yeah, it looks like we did, as you can see. So yeah. Or if the denominators are all the same to begin with, then you can just like multiply x plus 3 to both sides, and that just effectively cancels all of this out in one blow without doing any work. And you have 2x minus 5 minus x, and you can do 2x minus x, and you get x minus 5 is equal to 14. So after you have x minus 5 is equal to 14, let me just clear my screen. So let me just show you what I did again. So basically, you have to multiply x plus 3 to both sides, and that cancels this out, all of it, in one blow. And now you can, now you just get 2x minus 5 minus x. And I know what you're thinking, where did you get minus x from? I see the minus 5, but since this is like times this, since this negative is like to all of this, you have to like distribute the negative across to both of the numbers, and you get 2x minus 5x minus x. So yeah. So now this is equal to, so now this is equal to 14, because on the numerator over here you have 14. So yeah. Now you can like simplify this equation, and you got 2x minus x is equal to x minus.
Can you re-explain why you got negative x instead of plus x?
Okay. So the reason I got that is because there's a negative here, and yes, so yeah, there's a negative here, but that's only for the 5, right? Wrong. It's because this negative is for this whole fraction. So that means after you cancel the denominator, you need to distribute this negative to here and to here.
That makes sense.
Yeah. Okay, so now you have x minus 5 equals 14. Then you take this to the other side, and you get x is equal to 19. So did everybody get everything so far? If you have any question, ask them now.
I got it. Thank you.
Okay, seems like nobody has any questions. So let's do some practice problems. And to clear the screen. And the meeting is about to end in 2 minutes, so everybody please rejoin. So the first thing that we're going to do is we're going to do some practice problems on the thing that we learned first. That's 3.1 inverse variations. So yeah, let's get started doing the inverse variations. 3.1, yay. So the first question, let me do the first question as an example. Okay, so this is a really easy question. It says, which of the following is an inverse variation? And so I need to make everything bigger because it's super small. Oh, still doing the math. Okay guys, I guess this is gonna be a long day. Hope that works out fast. Is anything open? No, nothing's open. Shouldn't take this long. Okay guys, the meeting is about to end, so everybody rejoin. So yeah, the first problem, let me just say the first problem before the meeting ends. So which of the following is an inverse function? Obviously it's this one because we reviewed the rational equation or inverse variation. It's y is equal to k over x. Remember this? Yeah, this is called an inverse variation. So yeah, and this k is equal to a number. So this is actually a number. So you have to put a number in here, and don't worry about the y and x. The y and x stay variables. So the only thing like that answer is this one. So yeah, that's the answer that we get, and that is the right answer. So yeah, let's move on. Clear my screen. And the meeting is gonna end in just a second. So let's do one more problem. So who wants to do this one? Manya, do you want to do this one?
Sure, but what is PRT random question?
Where do you see that?
The formula I equals PRT to find simple interest.
Oh, that's the formula for simple interest. So it just says okay, the meeting is gonna end, so everybody rejoin, and I'm thinking it's gonna end. Oh, that's pretty cool. Okay. I'm just gonna wait for other people to join. I don't know if they are going to, because it's, I don't know.
Okay.
Oh, hey, Satvik's here. Hello.
Hello.
Why did everybody else leave? There were like 5 people in class to begin with, but then
Actually, there were 4 because you.
yeah. Why
No, there were. Neil was here at some point and then he left.
Okay. Okay.
At the very first day of class, we had 13 people, and now we have 3.
Yeah.
Actually, it's 2.
No, I think someone else was here.
Yeah. Well, yeah, they were, but like not right now.
Okay. So let's just get started with class then, because they're probably not gonna come back. I mean, they might, but I don't know. So, Manya, this is the formula for simple interest. So the formula is I equals P R T. So P is like the principal. So it's called, let me just get my annotation tool. It's called the principal, and that's like the amount that you first invest. So like you know banks, right? Like they have like a certain percent interest. So yeah, so that interest rate. So they have like a certain interest rate. That might be like interest rate, and that's like the amount that you earn per year.
Interest what you pay after you take a loan, like extra because you took so long to pay it back?
Yeah, but it's also what you earn, and this is like specifically talking about like the interest you earn from banks when you like store your money in them in your savings account or whatever. So yeah, this is interest rate, and the T is the time. So the time is like the time frame, and this says 9 years, and the interest rate is 9% for this one. It's 9%. Let me try and move this. I don't think I can. Oh, I can't. So the interest rate is 9, and the principal it says is 1,700. So you have equals $1,700, and the time frame is 9 years. Yeah, good job. It says 9 years right here. So yeah, so let me just match up the stuff with the variables. So the principal is obviously P. Interest rate is R because it's the rate. It's not like the actual interest. And the time is obviously T. So yeah, now you just multiply all 3 of these together and you get the... So the thing about this is, let me just...
How is this related to rational functions?
Because there's fractions and stuff. I guess, I don't know. So first of all, this time frame is going to be 9, but the interest rate, you have to divide that by 100 because this is actually like a percent. 9% is obviously 0.09, so that's why you have to divide this by 100. So you get 0.09 times 1,700 times 9. So once you calculate that, you get your final answer. So what did you get, Manu?
Let me get a piece of paper, solve this, and I will be back.
Okay.
Oh, answer those, I think.
Okay, yeah, sure, you can answer then.
It's $1,377.
Yeah, that's what I got too.
Okay. Seems like there's one
Yeah.
more person now. Okay,
I
cool.
think that seems right.
Yeah, okay. Yeah, that's what I got too. I just used the calculator. So let's move on. I think this is like loading super hard. It's like barely even working. I don't know why, I'm not even doing anything on it. So which of the following data sets best represents an inverse variation? Okay, so an inverse variation, remember like when the stuff goes up, like when the x goes up, y goes down. So yeah. If you want to do this one, raise your hand in the chat. Okay, Manya, you can do this one. So which one do you think it is? Yeah, I can hear you a little bit. I can't really hear you very well. Yeah, I can hear you better now.
Okay. Could you scroll up a bit though?
I think I know which one it is, but I'm not sure.
The very, very first one.
Let's find out. So let's try to find what equation this is. So obviously, when it's -1, it's 3. And when it's 0, let's try to find what it is when it's 0. So this goes up something every two things. So let me just use the calculator to figure out what that is. So we have 17, okay, oops, 17 minus 9 is 8, and we do 8 divided by 2, and you get 4 every time. So this is gonna go minus, this is gonna go down 4. So when it's 0, it's gonna be -1.
Yeah, this is in right because the x is increasing and the y is oh wait, that is right. Okay, wait.
Yeah. So obviously we get -1. Okay, yeah, -1 when it's 0. So now we can, like, I guess, plug this into the equation, or at least try to. So k is obviously like how much it increases or decreases, I'm pretty sure, like from 0 to 1 or something like that. Yeah. So which one do you think it is? Are you still sure it's the first one?
Not really.
Okay, so which one do you think it is?
It's not the second one. I think it's the very last one, actually.
Okay.
Wait, no. Yeah, I think so. No, that's not right either. Oh, wait, no. Yeah, that is right. Last one?
Yeah, but I'm pretty sure that's linear, and linear is bad because, like, I mean, linear is not bad, but actually, yeah, you're right. You're right. I'm pretty sure it is the last one. Let me just check it one more time.
Why is there a blank space in the last one? Like,
I don't know. I think it's just like a typo or something. So let's move on to number 4. So raise your hand in the chat if you want to do this one.
I don't see an option in the chat where I can raise my, I mean, not in the chat, but in the participants.
Oh, okay. It's in more. Do you see where it says like more, and it says like raise hand?
It just says invite, mute me, and then merge to meeting window.
Are you using the browser?
I use Safari.
Yeah, but like, is this from the Zoom app or are you joining from the browser?
Zoom app.
Okay. Well, there should be like a raise hand button, or there should be like a hand icon or something. I'm pretty sure. I don't know.
Okay, then oh, it's right here. It's in the reactions. Okay.
Okay. Yeah. I'm not a participant, so I can't like really see that. So, Satvik, you can do this one.
Okay, so I think this statement is true because like that's what you have to do to get well the answer in every equation that you need the interest.
Okay. Principal and rate are an inverse relationship, assuming that the variables are kept constant. Okay. Well, it says that the variables are kept constant, and I'm pretty sure they're not. They're not an inverse relationship, or are they?
But so like do you like the PRT have to be in order or something? Or no? Cause like
No, they don't have to be in order.
okay, then yeah, it's true.
Okay. Yeah. Actually, yeah, you're right. So, what kind of variation does the following data show? So, who wants to answer this one? Sri Lakshmi, you can do this one.
Okay, so what kind of variations does this following data show? Well, I would say it's direct, but I'm not really sure.
Okay, why do you think it's direct?
Well, I mean, it kind of, in my opinion, I guess, I don't know, looks like it would be. Like, I don't know how you would explain it.
Okay, yeah, that's fine.
Can I explain why I think it's direct?
Yeah.
The x is rising and the y is rising, and we've been learning about inverse variation where one variable rises and the other sinks. So it can't be inverse, so it has to be direct.
Y is decreasing? See, it goes from 24 to 19 to 15.
Yeah,
this
why is decreasing?
Then it would inverse.
No, but it's still direct because this is a linear relationship, and direct variations show like linear relationships. So a linear is where like it's just a straight line instead of what we're looking at. So let's just say that this is a graph. So this is what a linear or a direct relationship looks like. See, it's just a straight line. Whereas the inverse one looks something like this. That does not look like it. Okay, so it goes like that.
So basically, a linear would be like a straight diagonal line, and inverse would be curved lines going in the opposite direction.
Yeah, yeah, but linears don't necessarily have to be diagonal. They can be at any angle. They can be like that, or they can even be like that, just straight.
Okay, that makes sense.
Yeah, I think it's a direct. Okay, good job, everybody. Let's move on to the next question. So raise your hand if you want to do this one. Okay, Manya,
Are we, say?
what did you say? You go first.
Are we gonna graph one too? Like,
Sure, if you want to. Yeah, you can annotate.
I, okay, sure.
Let's say that this is the graph. It doesn't have to be exact. Can you just tell us the answer first, since it's so easy?
So like, do you have to graph it or something?
No.
Okay. Okay. Think.
Answer the question.
Yeah.
I think it's what? Okay, I think it's a inverse, cause wait, isn't K supposed to be on the top?
Yeah, you're right. That's why. Yeah, that's why it's a direct relationship, because this means it's 1/8 times x.
No, it's direct.
Yeah, it's direct. This is going to be a linear. See, the slope of this is 1/8. So it's going to go through the origin, and it's going to look something like this. It's going to look something like that.
X-axis.
What? I couldn't really hear you. You were glitching out.
It's gonna go really close to the x-axis.
Yeah, because what 1/8 means is that so it's gonna go every time it goes 1 up, it's gonna go 8 across. So yeah, it's gonna be like really it's gonna be very horizontal, kind of. So let's go on to the next question, and if you want to do this question, then raise your hand in the chat. Sri Lakshmi, you can do this one since you raised your hand first.
So basically, the x-axis goes down, or I mean raises up, and the y-axis goes down. So, and inverse variations do that. So I would say this data does show inverse variations. That's a yes, I believe.
Okay. I also think it's a yes because it's not very even, like the curve. See, at 1.2, it's like 131, and at 2, it's like 75. It goes down super fast. And then when it goes from like 2 to 10, it only goes to 16. It doesn't go very far. And 10 to 46, it only goes down like 10, close to 10. So yeah, I think I also think it's an inverse variation. So let's move on to the next question. If you want to do this question, then raise your hand.
Okay, but why is there slash multiplied by slash slash?
I don't know. I think it's a typo. Or it's a glitch. I don't know. Okay, Manya, you can go for this one.
Okay, let me just read the question first. For interest per year, does that mean for percent interest per year, or like $4 interest per year?
For 4% interest per year. It's 4%.
So basically, I would just find 4% of 120 and multiply it by 4.
Yeah. You would actually multiply 120 by 0.04 and then multiply it by 4.
Yeah.
Yeah. Because it's a percent, it's like divided by 100. So.
Yeah.
Oh, yeah. The answer gonna be $12.
Well, let's see. It's 120 times 0.04, and you get 4.8 times 4. I think it's actually 19.2.
Yeah, it's $19.20.
Yeah. It's 120 times 0.04, and then times 4. I think it's actually 19.2. So good job, Manya. I think you should use a calculator. Maybe. It's probably going to make it faster. Unless you don't want to. It's fine if you don't want to. So let's go on to the next question, number 9. Does the following data show inverse variations? This data. So Satvik, you can go for this one.
I think no, because for the x-axis it's decreasing, and for the y-axis it's like it's increasing.
Okay. I think
Right.
yeah.
I don't think the y-axis is increasing necessarily because
It is,
at a decimal place.
yeah.
Yeah, but
It's still increasing though. Yeah, and if it's like going down and this is going up, then that means it might be an inverse variation, but you have to check if it's like not linear. So you have to check if it's like the difference between this and this and this and this is the same as this and this and this and this. Kind of, if you get what I mean. Like the ratio is the same. You want to check if the ratio is the same.
Oh, okay.
So we can do negative. Okay, oops. Get this out the way. Okay, so that's negative. Sorry, just 3 divided by 50. That's 0.06. So that's going to be negative 0.06. And now let's do 0.75 divided by 12.5, and you still get 0.06. So that actually means that it is a direct variation. So you're right, Satvik.
Okay. So it's no, right?
Yeah, it's not.
So
Okay.
does that mean that it's not a linear equation?
It is a linear equation. Because it's not an inverse variation, it's a direct variation.
Okay, makes sense.
Yeah. So the how you can check that is you have to divide like the x by the y, and you have to do that for all of these. And if it like matches up for all of them, then that means that it's obviously a yes. Sorry, a no, because right now it's asking for inverse variation, but it's a yes if it's a direct variation. Then, so if like the division between this and this is the same, then it's a direct variation. It also means it's linear. So let's go on to the next question, number 10. Using the formula I equals PRT to find simple interest on an account, find the amount of interest earned in 6 years if you deposited $3,000 into a savings account earning 9% per year. Sure, Lakshmi, you can go for this one.
Okay. So 3,000 times 0.09, and that's times 6, and then that would $1,620.
Okay,
Yeah, that's correct.
oh, that's 1,620. Okay. So good job, Sri Lakshmi. Let's go on to the next question, number 11. Graph the equation using a graphing calculator. Is a function an inverse or a direct variation? So you don't need to graph. Just tell us how you found either if it's not or if it's a yes. Okay. Manya, you can go for this one.
Second. Okay, I'm back. Sorry. So I think it's a direct variation.
Okay, so why do you think so?
K is supposed to be at the top, but it equals K, and it just doesn't look right.
Okay. Good reason, but yeah, that's half correct. It doesn't look right because basically the x is on the bottom. So when you solve for y, which is what most equations look like, it's y equals k x or k over x or whatever. It's actually solving for y. So y is equal to this. So that means that you have to solve for y in this case, and you get y is equal to 14x.
Okay, so basically, if x was on the top, it would be an inverse equation?
No, if x was on the bottom, then it would be an inverse equation. If
Okay.
x was on the bottom and 14 was on top, then it would be an inverse equation.
Okay.
So my answer was right, but my reasoning wasn't?
Your reasoning was not completely right. Yeah. So, Satvik, you can go for number 12. Graph the equation using a graphing calculator. You don't have to do that. Is the function an inverse variation?
I think it's no. Well, because it doesn't look right, and for it to be an inverse equation, x has to be on the bottom and 7 has to be on the top, right?
Yeah.
Okay.
Okay. So it's actually a yes. It is an inverse variation because last time, if you remember here, it's y over x. Over here, it's x over y. And this is not like upside down. This is not 1 over 7. This is just normal 7. So that means that if you like solve for y in this case, you get x or if you solve for y in this case, then you're going to get something like y is equal to 7 over x. Let me check that. 1 second. So the first thing we have to do is we have to get y to the other side. So we have x is equal to 7y. And now we divide 7 on both sides. So yeah, you're actually right. It's not an inverse variation, it's a direct variation because you get y is equal to x over 7. And since x is on the top, then it's yeah, you're right. Since x is on the top, it's not an inverse variation. So let me just select that answer. What kind of variations does the following data show? That's number 13. So raise your hand in the chat if you want to go for this answer. If you want to go for this question. Sri Lakshmi, you can do this one.
Okay, so the x-axis increases and the y-axis decreases. And so I think this would be an inverse variation.
Good job. And so let's actually check if this is right. So remember how we check? We have to do 7 over 20, and that's 0.35. And we do 2.8 over 50, and obviously that's 0.056. So it's going to be an inverse. It's definitely not a direct variation. So yeah, it has to be an inverse. Good job, Sri Lakshmi. So let's just do one more and you guys can have a break. So number 14, actually let's do two more until 15, so yeah. So you have 14, if you want to do this one, then raise your hand. Manya, you can go for this one.
Can I use the calculator?
Yeah. Yeah.
I have one on my computer. Okay. So it would be 0.06, right?
Yeah.
Okay. For you. Is the answer $28.8?
Yeah, that's what I got. Did everybody else get that?
Yes.
Yeah.
Okay, good. Good job, everybody. We're gonna do this last 15th question. So, if you want to do this one, then raise your hand in the chat. Nobody wants to do this one? Oh, okay. Sri Lakshmi, you can go for 15.
Well, this is kind of a bit weirder problem because both of them decrease. And so, since both of them do the same thing, then I would say this would be a direct.
Okay, but let's actually check using the actual way. So there's 17 divided by 20, that's 0.85. So now we do 13.6 divided by 16, and that's also 0.85, so obviously that's a direct variation. Good job, Sri Lakshmi. You can have the break until the meeting ends. You can have break until the meeting ends, and everybody please rejoin.
Well, what?
The meeting is about to end in like 6 minutes. Yeah, 7 minutes. So you can have break until then, until the meeting ends, and I have to like start the meeting again.
Okay.
stream on. Just a second. I mean, I did turn the live stream on. I just forgot to actually turn it on. Can you guys see the screen? So when it's break time, I pause the screen share, kind of, if you know what I mean. And I forgot to turn it back on.
Files and just files.
This?
Yeah, what happened?
That's the software that he uses to stream it.
Yeah. So yeah, it's finally loaded. So let's get started doing rational equations. Self-check 3.2. Okay. Boom. And this should come up pretty quickly. There we go. We're not going to do this essay question because we're... What?
A second ago, the only thing I saw was code.
Yeah.
Yeah, me too.
Yeah. I guess they use the code to write down the equations and stuff. Okay, so solve the equation. If the equation has no real solution, write no solution. Okay, guys, if you want to do this question, then raise your hand in the participants list.
Can you do this one as
Okay.
example problem?
Yeah, sure. Okay, so let me just do it as an example problem. Okay, so let me go to drawing tool. Solve the equation. If the equation has no real solution, I'm gonna do that. Write no solution. Okay, so that's the equation they gave us. So the first thing we have to do is look at this, and as you can see, there's fractions, which are disgusting and ugly, and they deserve to die. So we're gonna kill them by canceling them out, by multiplying this and this. So now we're gonna do x minus 4 times x, and we're gonna multiply this to both sides of the equation also. So basically this cancels out the x minus 4 over here, and now we have 2x plus 7 left times, and this is multiplied by x because the x minus 4 got cancelled out on this side, and this is equal to 2 over x times x minus 4 times x. So over here on this side, the x gets cancelled and the x minus 4 stays. So we have 2 times 2 times x minus 4. Now we just simplify both of the sides and we get 2x squared plus 7 is equal to 2x minus 4. Sorry, that's minus 8. It's supposed to be a minus 8. And this over here is also supposed to be a 7x because this is supposed to get distributed to both sides. Like that, and this is supposed to do that same whole thing also. So, there we go. So now we can bring this to the other side to, isolate x, and we can maybe use factoring to solve the problem. So, we get 2x squared plus 7x minus 2x, so that's plus 5x, because 7 minus 2 is 5, and then we have plus 8 also on this side. Equals 0, because there's 0 on this side. When we got the 8 to the other side, turned into a 0. So now we can maybe use factoring to solve this. So 16, let's see. So 8 times 2 is 16, 16 times 1 is 16, and seems like we did something wrong, maybe. Yeah, I think we did something wrong. Let's backtrack for a second. Okay.
Would it be -8 -8 instead of +8?
It would be a positive 8 because over here it was x minus 4 times 2, and that was a -8. And then when we added 8 to both sides, there was a +8 over here, and there was a 0 over here. So I think it would still be a positive 8.
Okay.
I think we did something wrong, but I really don't know. Maybe this is just a no solution. Let's just use a calculator for this. There's lots of online resources, good ones and bad ones. So let's open up a new tab. And algebra calculator because I'm way too lazy to do this. mathpapa.com/algebracalculator.html. And so this website like automatically calculates the stuff for us. So we basically don't have to do any work at all. We just put the equation in here and gives us the answer. Magic. It's actually not magic, it's called computer science. Which is sorcery, so I guess you can call it magic. So let's plug in this equation into there. So that's, come on. So that's 2x squared plus 5x plus 8 equals 0, and we can calculate it. And it should solve the equation for us, and there's no real solutions. So yeah, I think we got it right. I think it's a no solutions. Okay, so
Question like number 2.
no, we're not gonna do number 2. It's an essay question, so yeah, we don't need to do that one. That one's stupid. Okay, so number 3. Who wants to do this one? Okay, Sri Lakshmi, you can do this question, but I recommend you not to use algebra calculator. I just used that because to check my work, because I thought, yeah. So don't use the algebra calculator because well, you're not going to be learning anything.
Yeah, I won't.
Okay.
So first of all, I'll do this on this one.
Okay.
13x divided by x squared equals 45 minus 5x divided by x. Okay, so then we would multiply both sides by x minus 9 times x squared. So then that would be like that. And then squared. Okay. And then the x squared on the left side would cancel out, and the x minus 9 on the right side would cancel out. And then we're left with basically what is it? 45. Wait, I'm sorry. 13x times x minus 9, which equals 45, x squared times 45 minus 5x. I'm sure I got that right.
Looks right to me.
Okay.
Okay, so what are you going to do next?
So then I would distribute them. So 13x times x, that would be 13x squared, I believe. Yeah. And minus 13 times 9 would get me 117, which equals 45x squared minus 5x cubed would be 5x
Yeah.
cubed. Okay. Okay. And then I would subtract 13 x squared on both sides. And then I would get negative 117.
I think it's a positive. Because this is a negative over here, so when you bring it to the other side, it becomes a positive.
117 equals 45 minus 13 is 32.
Yeah.
32x squared minus 5x cubed. And then you can add, can we add 5x squared on both sides and 5x cubed on both sides?
I don't think we need to. See, we already have everything on one side. Now I guess all we have to do is try to factor it or something. Actually, let's just use the calculator for this.
Well,
Okay. 5x cubed.
Is
Plus-
it 9?
Well, let's figure it out. Might be. Okay, there are no like terms. Okay, it has to be equal to 0. It's negative 6.8. It's actually negative 6.9 or 89, whichever. Okay, nearest 100. Yeah, that's the answer. Okay, well, okay, so if you want to do number, excuse me, if you want to do number 5, raise your hand in the participants list. We're only going to do a few of these. Okay, Manya, you can do this one.
I need to go get a pencil and a paper because I put it away.
Okay.
Okay, I'm back. So, can I solve it and then tell you how I did it and everything? Okay, thank you. or no?
Sorry, I wasn't listening. I was gone.
All the same.
Okay, good. What did you get?
Is the answer 67 on 7? Like over 7?
Well, can you tell us how you got that?
Sure, 1 second. Let me find it on my paper. The first step. No, I didn't get 57. I got 67.
Okay. Let me just rewrite it.
I can't find the first step on my paper.
I-
There's too many steps.
I think the first step would be to multiply both sides by 18. Did you do that?
I think so. I can't understand my handwriting.
Oh, well. Okay. So this is how I would do it. So basically I would multiply both sides by 18, and then I would get 2 on this side because 18 divided by 9 is 2, and then 18 divided by 2 is 9. So you get 9 times x minus 7, that's 9x minus 63 is equal, okay, 9x minus, okay, oops, 9x minus 63 is equal to x plus 2 times 2. So that's 2x plus 4. Okay, that looks like this. Okay, 2x plus 4. And now I would bring this to this side and this to this side. So I would have 9x minus 2x, 7x, is equal to 63 plus 4, that's 67. And yeah, so it seems right because x is equal to 67. Excuse me, 67 over 7. Okay. And were you saying something?
Why don't you turn the fraction into a decimal?
No. I'll just do it. So that's 67 divided by 7, or it's 9.57. That gives us, let's just see if we can put it in a fraction. Okay, no, we can't put it in a fraction. That's 9.57. Perfect. Okay, let's clear the page. Okay, Satvik, you're the only one left. After you do this, we can maybe do one more round for all of you, and then class will be over.
What question are we doing?
Number 6. This one's easy.
Okay. What does LCD mean?
Least common denominator.
Oh.
Basically,
Okay.
it's just asking you to multiply these. Kind of.
Oh, okay. Can I have time to solve it, and then can I tell you how I solved it?
Yeah, sure.
Okay. Hello, are you guys back?
Yeah, I'm here.
Okay, I'm just gonna check my work and okay.
Okay.
I think it's uh the fourth one.
The fourth one, you mean this one?
Yeah.
Okay. Uh. Okay, good job. Yeah, that's right. I'm pretty sure. Yeah, it's right. But I think they wanted you to pick this one because it's in like simplest form or something. I'm pretty sure the right answer is this one.
Okay, but
Yeah, both of these are right though.
okay, so did I get it right? Did I get it wrong? I don't get it.
You got the answer. You got the LCD right, but you got the answer for the question. I'm pretty sure wrong, unless both of these are right. I don't know because both of these answers in real life they're right. I'm pretty sure.
Can you pick both of them?
No,
Oh,
only choose one. But I'm thinking since this is in like simplest form, I'm thinking this may be the correct answer. So yeah. So let's also go on to number 7. If you want to do this question, then raise your hand in the participants list. Sri Lakshmi, do you want to do this one?
I don't really like get the fact of square roots, I guess.
So you don't need to do square roots for this question.
Okay. Then, so do I just multiply like the denominators or?
Yeah.
Okay. So.
Remember FOIL?
Huh?
Do you remember FOIL? Like the FOIL? Like first, outer, inner, last? Do you remember that? Okay. Well, let's say, let me just give you an example. It's not related to this question at all. I mean, FOIL is related to this question because I'm pretty sure they want you to like multiply these two. But FOIL is when you have like first, outer, inner, last. FOIL. So basically, that's when let's say you have x plus 1. Okay, it looks like we're running out of time. So we have x plus 1 times x minus 5. Okay, so let's just say we had that. So now we have to do the first, we have to multiply the first things together. We have x squared, because x times x is x squared. And now we have to multiply the outer ones, so this is this first one and the last one. That's negative 5 times x, that's negative 5x. And then you have the inner, that's,
So that would be 1x.
yeah, so that's plus x. And then you have last again, so that's 1 times negative 5. That's minus 5. And now we just simplify this to x squared minus 4x. Remember, that's because negative 5 plus x, negative 5x plus x is negative 4x. Okay, so yeah, that's how you get like this answer thing from this.
So then I will also do that here.
Yep.
So that would be x squared plus 6x plus 20.
Okay.
And
That's
then,
actually 24. It's actually 24.
oh, 24. Yeah. And then if we simplify that, we can subtract 4x from both sides, I guess.
No, you just have to add 4x and 6x.
Oh, 4x and 6x, and that would be 10x.
Yeah.
So x squared plus 10x plus 24.
Yeah. I think that's it. Good job.
Isn't it time to go?
Yeah, it's time to go. I was just about to say. So yeah, I'll see you guys tomorrow.
Okay, bye.
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 Okay, bye stream. See you